Hello, this is moles video number 3. This one's about the volume of gases. It's AQA 4.3.5, which is higher tier chemistry only, so not combined science. Recapping from the first two videos, 1 mole is 6.02 times 10 to the 23 of anything. Now there's some really good news for you about gases. 1 mole of any gas has a volume of 24 decimeters cubed. That's right, every gas, any gas, they all take up the same volume in space. Which means that this is going to be really quite a nice, easy little topic. Quick note though, make sure you know what 1 decimeter cubed is. It's equal to 1 litre, and 1 decimeter cubed is equal to 1,000 centimeters cubed. Do watch out the examiners, because essentially you're only using one number. They will try and make you work for it by giving you the volumes in centimeters cubed, and you'll have to divide them by 1,000 to get to the decimeters cubed. Okay, let's just show quite how easy this is. I've just said 1 mole of any gas has a volume of 24 decimeters cubed. What about 1 mole of oxygen? 24 decimeters cubed. Okay then, what about 1 mole of nitrogen? 24 decimeters cubed. Okay then, argon, think of the pirates. Nope, still the same, 24 decimeters cubed. It really doesn't matter. In the exam, they might give you a gas you have never heard of. Guess what? 24 decimeters cubed. Alright then, how could they mess with you? Instead of telling you you've got 1 mole of it, they could say, you've got 6.02 times 10 to the 23 molecules of carbon dioxide. Hang on, 6.02 times 10 to the 23? Hey, that's 1 mole. 24 decimeters cubed. Alright then, the examiners, they know you've got this, they'll turn it on its head. They tell you that they have got 24 decimeters cubed of neon, and that has got what in it? Well, 24 decimeters cubed is 1 mole. It's got 6.02 times 10 to the 23 atoms. I say atoms because there's no number there, which means it's a 1, which means it's floating around as an atom. Atom, argon, atom, neon, molecule and molecule and molecule, because there's more than one atom. Right, we need an equation. For mass, number of moles, it's the sample mass divided by the molar mass. Here, it's basically the same thing. Number of moles is the sample volume, and it's going to be divided by the molar volume. But we don't need to put a capital V, we simply put 24. And just remember that up top, that needs to be in decimeters cubed. Let's try this out. Here's the question. What is the number of moles in 48 decimeters cubed of? Well, starting with oxygen. Why not go with an easy one? Here's the equation. Number of moles, volume over 24. You simply look in the question, find it's 48, double check the units, yep, divided by 24, and that equals 2 moles. Please note, I've written out the equation every time. You know I know the equation, why am I writing it out? Because in the exam, you're proving to the examiner how much you know. You're proving to them that you know what to do. And also, when you accidentally do 24 divided by 48 in your calculator, you might still get some error carried forward, some marks for working. So show them everything you've got. Okay. Oh no, they've asked about nitrogen. But wait, it's the same equation. It's just 48 divided by 24. It is 2 moles. And what about if it's hydrogen? It's exactly the same. It doesn't matter which gas, it is always the volume divided by 24. So there you go. Each of these 3 gases, same volume, same number of moles. Okay, they might twist it round on you. Here is our equation. We're going to put it into the triangle. Sample volume on the top, number of moles, and 24 down below. See if you can take a moment and rearrange it. The volume is 24 times the number of moles. So if you want to take a moment and see if you can do the question, what is the volume of 4 moles of carbon dioxide? We do 24 times the number of moles, 24 times 4, and that one is going to be 96 decimeters cubed. Okay, so because it's the same thing every time, what they might do is get you to combine a couple of equations. Here is a really similar example to the kind of thing you get in the exam. It's worth 4 marks, which means I need you to do 4 steps. Try pausing and having a shot at this before you watch me go through it. So, Audrey has 0.4 grams of a mystery gas. This gas has a volume of 2,400 centimeters cubed. Which gas is it? Right, this is where you need to go through and think, what is it asking me? To identify the gas, you need to know, well, the mass of 1 mole. And we know we have to use mass because there's a mass given there. So, the number of moles is the sample mass divided by the mass of 1 mole. So if we rearrange that, the mass of 1 mole is the sample mass divided by the number of moles. Okay, we've got a sample mass, but we don't have a mass of 1 mole. But we do have a sample volume. We know from the work we've just done in this video, the number of moles is the volume over 24. However, we've been given in centimeters cubed, so we're going to need to divide by 1000. 2,400 divided by 1000, this is 2.4 decimeters cubed. So that is your first mark. Now, try plugging it into the equation. 2.4 divided by 24 is 0.1 moles. That gives you the second mark. See if you can figure out where to go from here. So we wanted to get the mass of 1 mole. So we do the sample mass divided by the number of moles. Sample mass up there is 0.4. The number of moles is 0.1. So this tells us that every mole has a mass of 4 grams. Third mark for there. Final mark is going to be for looking us up in the periodic table and discovering that the gas with a mass of number 4, so therefore the mass of 1 mole being 4, is helium. Thank you.